Hi everybody, I hope you are good and doing well. Today we'll study a new type of permutation. Until now we studied that types of permutations which there was linear arrangement. But if we want to arrange them or order them in a circular order, so what should we do? Let's look at this example. As you see, we arrange 1, 2, 3, 4, 5, these five the five digits in different ways. As we have five elements, so we have 5 factorial or 120 different linear arrangement for them. But let's see these two, two of them, these two linear arrangement of them. 1, 2, 3, 4, 5, and 3, 4, 5, 1, 2. If we connect both ends of these lines or this linear order, we will get a circular arrangement which if we look at the clockwise order of them, that will be 1, 2, 3, 4, 5, and the clockwise order of the second one, 1, 2, 3, 4, 5, is also the circular order of them. Without considering the top element, as we see for two different linear arrangement, we have two same circular arrangement. It means there are difference between linear arrangement and circular arrangement, or the number of linear arrangement and number of circular arrangement. Let's see it at another example. As you see in here, we have three letters A, B, C. So if you want to find the number of linear permutation or linear arrangement or linear order of them, we can find it by 3 factorial, which is 6 different linear arrangement. But for a circular arrangement, as you see, we have 2 different arrangement, which is ACB clockwise, and also ABC. And these two are circular arrangement for clockwise or anti-clockwise ABC and ACB. Like this. How can we find the number of circular arrangement? We can find the number of linear arrangement by factorial, but how can we find the number of circular arrangement? For these three elements, A, B, C, we take one of them as a constant place or at the same position, but change the other two. The position of the other two elements. If we take A at the same position and change the place, two other elements will be left, which is BC. If we change the place of the position of BC, we will get ACB and ABC, two different arrangements. It's for 3 elements. If you want to find for n elements, so what should we do? Let's talk about that. As we see in the previous example, we have 3 elements, and we take or we put one of them as a constant position, or we locate them as a constant position and change the place of the other 2. So let's do it for the other circular permutations. For example, if you have one object, so we put that object at the constant location, so there will be no other object to permute it, or how many in permutation in that case? We have 1 minus 1, because one of them is constant and we don't have any other permutation or any other element to permute it. For example, if you have 2 objects, so we put one of them as a constant position, so how many objects will be left to permute them? 1. So 1 factorial or 2 minus 1. The total number is 2 minus 1. 1 is the constant one, which we put it at constant position. So 2 minus 1 factorial will be the circular permutation of that. For example, if you have 3 different objects, if you put one of them as a constant place or constant position, so the remaining elements will be 2, so 2 factorials or 3 minus 1. 3 is the total number, 1 is the constant one, so 3 minus 1 factorial will be the number of permutation for circular permutation for 3 objects, and so on for 4 number of objects. If you want to circular permute them circular. So in this case, we put one of them as a constant position, and the other 3 will be permuted. So 3 factorial or 4 minus 1 factorial will be the number of circular permutation for 4 objects. If you have n objects, so one of them is constant, so n minus 1 element will be left to permit them. So the total number of circular permutation for n elements will be n minus 1 permutation. As a conclusion, we can say that if we have n elements, so the number of circular permutation is n minus 1. N is the total number of objects, and 1 is that object which we put it at the constant position. So how many elements will be with them? N minus 1 factorial will be left. Let's see this subject in an example. In how many different ways can 5 girls sit around a circular table for dinner? It means we have a circular permutation or circular arrangement in here, and the total number of the girls or the objects are 5. So the circular permutation will be 5 minus 1 permutation, which is equal to 4 permutation, and is equal to 4 times 3 times 2 times 1 is equal to 24. We have 24 different circular permutation for these 5 girls. Next example. In how many different ways can a family of 2 parents and 4 children sit around a circular dining table? Circular, it means there is a circular permutation. If the parents must sit together, as we have in here a restriction or a condition that parents must be as one element, it means we accept 2 parents as one element and 4 children. So the total number of the elements or objects in here will be 5. 1 plus 4. So 5 permutation, 5 minus 1 circular permutation. But as we have 2 parents in here, so we have also a permutation or an order between the parents also. So times 2 factorial, which 5 minus 1 is 4 factorial, and 4 factorial is 24, and 2 factorial is 2, so it's equal to 48. So we have 48 different arrangement for this condition, or for this circular permutation with 2 parents and 4 children, which parents must sit together. Another example. A room contains a circular table with 5 chairs and a bench for 3 people. And how many ways can 8 students be seated in the room? It means we have a circular permutation and also linear permutation at the same time. The total number of the students are 8. So firstly, we should permute these 3 students in linear permutation. So what will be the permutation of them? Permutation of them will be permutation of 3 from 8 times. So how many elements will be left in that case? In that case, 5 elements will be left to permit them in circular arrangement. So 5 elements, the total number is 5 elements. So circular permutation is 5 minus 1 factorial. And it's equal to, if we find them, or if we find the product of them, if we multiply them, we will get 8 factorial. Permutation of 3 from 8 is 8 factorial over 8 minus 3 factorial times 5 minus 4 is 5 minus 1 is 4 factorial, and it's equal to, if we multiply them, we'll get 8064. Which means how many different permutation or seating arrangement will be there? 8064 different permutation will be there. 3 of them are linear and 5 of them are circular. Check yourself. 10 is your homework. You can do it at home. If you have any question, you can call. You can get in contact with us from our school WhatsApp number, and we'll respond to you. Thank you.